Hello, my name is Cabe Rieck, and today I'm going to be solving this problem. So we're given a piecewise function f of x, and we're asked to find the values of a and b so that f of x is continuous. So, first of all, we can see when x is less than 2, this function right here should be continuous everywhere except at 2. Because of the denominator. So we can say that f of x is continuous on the interval negative infinity to 2. So then next we can see that this function right here would be continuous from 2 to 3. So, in fact, that would be continuous everywhere. So if we're going to say f of x is continuous on the interval 2 to 3. And then we also see that when x is greater than 3, we have this, which should also be continuous everywhere. So we can say that f of x is continuous on the interval 3 to positive infinity. So, now the only spots that we need to look at are 2 and 3. So for f of x to be continuous everywhere, limit as x goes to 2 negative of f of x is equal to limit as x goes to 2 positive of f of x. So we're setting the left and right limits the same as each other. And also limit as x goes to 3 negative of f of x is equal to the limit as x goes to 3 positive of f of x. Once again, setting the right and left limits equal to each other. So we have a defined limit over that. So the next thing is we can define these different limits. So limit as x goes to 2 negative of f of x, we can see that that is going to be using this right here. So this is going to be equal to limit x goes to 2 minus of x squared minus 4 over x minus 2. This guy up here. And we can say that this is equal to limit as x goes to 2 minus of x plus 2 times x minus 2, because that's the conjugate, over x minus 2, which is equal to the limit as x goes to 2 minus of x plus 2, which is simply equal to 4. So our left limit at 2 is equal to 4. Now we'll do our right limit at 2. When we're coming from the right side, we're going to be using this ax squared minus bx plus 3. So this f of x is equal to limit x goes to 2 positive of ax squared minus bx plus 3, which is equal to 4a minus 2b plus 3. Now we'll do our right and left limits at 3. So at 3 from the negative side, we're going to be using this guy as well. So that's going to be equal to limit as x goes to 3 minus ax squared minus bx plus 3, which is equal to 9a minus 3b plus 3. Last one of these limits we have to do is the right side of 3. So when we approach from the right side, we're going to be using 2x minus a plus b. So this is equal to limit as x goes to 3 positive of 2x minus a plus b, which is just equal to 6 minus a plus b. So now that we have our different limits, we're going to set them equal to each other. So the two limits are going to be set equal to each other. So that's going to be 4a minus 2b plus 3 is equal to 4. And we can rewrite this to say that 4a minus 2b is equal to 1 if we subtract 3 from both sides. And then for the left limit, we can say that 9a minus 3b plus 3 is equal to 6 minus a plus b. And we can bring this to, if we add a to both sides, we get 10a on this side. If we subtract b from both sides, we get minus 4b on this side. Subtract 3 from both sides, and we get 3 on this side. So now we have our two equations, and we can use them to get the answers for a and b. So if we have 10a minus 4b equals 3, then we can use this equation to get rid of b. So we're going to go minus 8a plus 4b minus 2, because these should be equal to each other, so we can do them on either side. So then we end up getting 2a is equal to 1, which means that a is equal to 1/2. So we can write this over here. A is equal to 1/2. Put that guy in the box. And then next, we can plug this in, and we can use either, but let's use this one, 10a minus 4b equals 3. So if you plug in a, you just get 5 minus 4b equals 3. So plus 4b on both sides minus 3 on both sides. You get 2 is equal to 4b, which means that b is also equal to 1/2. So over here, we're then going to say that b equals 1/2. And now we have found the values of a and b, so that this function up here is continuous everywhere. Thank you.